Hello, students. In this video, I'm going to discuss uh, memory-based questions and answer of Jest 2025 exam, which was held today. So let's start. See, I have written down briefly the solutions of these questions. Okay, if you are interested in solution, you can just have a look on the slides. So you will get an idea how I have solved these questions. But I'm not going to solve these here in details. I'm just telling you um, answers of these questions. Okay. And if you have any query, you can ask your query on this number. Okay, so this is the official number of Optimist classes. Okay, so and if you remember some questions which are good, actually you could not solve them. Okay, then you can send those questions on this number. I'll try to provide solution. Okay. So whatever question I have got, some are good questions, some are easy questions. I'm providing answer to those questions here in this video. Okay. If I receive some good, some more good questions, okay, then I'll try to make another video. All right. So let's see. This was a question from Matrix, and some information about its equation was given. It is satisfying this equation, and trace was given to be this. So using Cayley-Hamilton theorem, you can convert this equation into eigenvalue equation and all that. Trace was given, so you solve this and this. Okay, and ultimately determinant. You know that determinant is product of eigenvalues. So you will get eigenvalues 1, 2, and from 1 to when you put here, you will get another eigenvalue 3. So product of that will be equal to 6. Okay, so answer is 6 here. So I think I should not explain this much also. Okay, see. This is a question related to a pendulum. Okay, so there was a pendulum oscillating, and now so in one case there was only a pendulum. Its time period was t1. Okay, time period is t1. Now question is some charge is given to the pendulum. So this is a pendulum, and it has been given a charge, and now it is under this pendulum there is a sheet placed. It has charge density sigma. So in this case the time period of pendulum becomes t2. So question is, what is the value of t2 by t1? Okay, so here I have briefly written the solution. Okay, so this is my own way of getting the solution. So by doing this much calculation, I was able to get the answer 2. Okay, so here answer is 2. You can look at this solution if you want. Okay, so answer for this question, remember, should be equal to 2. Okay, now next question is, so there is a muon particle which has average lifetime is equal to this much, 2.2 microsecond in its rest frame, and it is traveling with a speed of c by 3. So question is, what distance is it going to travel? So this is a very common question. Okay, this question has been asked many times in different examinations. Okay, so you solve it like this, and the answer that you will should get is 233 meter. Okay. Next question is, it is related to an electromagnetic wave propagating in isotropic and homogeneous medium. So question says, which of the following is correct? So we know that in plane electromagnetic wave, electric field and magnetic field are perpendicular to each other. So therefore dot product has to be 0. So therefore this option is correct. So this was, I think all these questions must be in marks 1. Okay. All these must be 1 marks question. Okay. Because these are extremely easy questions. Okay. Now question is, this is an operator, okay, and its eigenfunction is this much, e to the power x. So question is, what is the eigenvalue? So you just plug in this here, okay, operate this operator on this function, and since exponential after differentiation also remains exponential, so it will remain e to the power x. It will remain here e to the power x, and e to the power x you will get, and e power x common लेने पे e power x का जो multiple आएगा ना वो यही आएगा. So that is the eigenvalue. So this should be the answer. Okay. So now another question, it says for a quantum mechanical system, there is an operator A which has eigenstates K1, sorry, A1 and A2 with eigenvalues A1. Okay, and here eigenvalue is E2, and this ket A2 is its eigenstate. Okay, so question says expectation value of this operator in this state. Okay, in this state we have to calculate. So what I have done is this. I have just operated this operator on psi. Okay, cat psi पे हमने operate किया है, ठीक है. So we have just first operated a minus a2, and then we operated a minus a1, and we are getting this 0 here. Okay, so when you are operating a minus a1 and a minus a2 on this cat psi, you are getting 0. So obviously expectation value will be 0. So therefore answer is 0 here. Okay. Next question. See, it says for a 2D Fermi gas at 0 Kelvin with Fermi energy EF, average energy. So here I have done the calculation, okay, using this formula. Okay, so correct answer should be EF by 2. Okay, so correct answer is this one. Okay. Now question says partition function for a two bosonic particle, ठीक है ना, two particle system है basically. There are two bosons, okay, at temperature T. So there are two bosons here at temperature T. Okay, so for this system, and these bosons can occupy two energy levels, epsilon 1 and epsilon 2. So for this system, we have to calculate partition function. We have to write down the partition function. Okay, so if you consider distribution of particle in two energy level, this is the distribution, or according to that you are getting total energy 2 epsilon 1, 2 epsilon 2, and epsilon 1 plus epsilon 2. So obviously the only answer, the correct answer will be that in which these energies are present. So you are seeing that 2 epsilon 1, 2 epsilon 2, and epsilon 1 plus epsilon 2 is present in option C. So therefore option C, this type of option will be correct. Okay, which contains 2 epsilon 1, which contains 2 epsilon 2, and which contains epsilon 1 plus epsilon 2. Okay, this type of option will be correct. Okay, next question. It says lattice contribution to CV at 2 Kelvin is this much. Okay, and what will be corresponding contribution at 4 Kelvin? So here is the description. Okay, so using this description, if you calculate, you will get, you will see that CV is getting multiplied by factor of 8. Okay, so therefore correct answer will be 4. Okay, so 4 is the correct answer. Now it says there is a Lagrangian given, and question is for this system, what are the conserved quantities? You can see Lagrangian is not explicitly time dependent, so energy is conserved, and there is a factor of x square plus y square. So here actually Lz is conserved. Okay, Lz is conserved, and actually particle is moving on xy plane, so it has only z component of angular momentum. Lx and Ly are 0. Okay, so therefore we can say that angular momentum is conserved. Okay, so therefore correct answer will be that energy and angular momentum. L primed I have written for angular momentum. Okay, so angular momentum को L prime से denote किया जा रहा है because we have written L for the Lagrangian. Okay, so therefore correct answer will be in both energy and angular momentum are conserved for this system. Okay, next question is, see, this is somewhat basically calculative question. Okay, so not too calculative. Whatever calculation is required, that has been done here. Okay, you can see first this part we have done. Okay, this is the mass calculation, and here this side moment of inertia calculation has been done. Okay, so question is, there is a circular disk, and it has surface mass density equal to this much. Okay, and its mass is capital M and radius is capital R, and so moment of inertia, so basically it is something like this. So this is a disk, and we about this axis we have to calculate moment of inertia. Okay, so if you do calculation, first you will have to calculate mass, okay, and then you will have to calculate moment of inertia like this. Okay, so we are getting this answer. Okay, so correct answer is should be this one, ma square. This ma square is the correct answer. Okay, so this was a very basic question, testing students' calculation ability. Okay, so very basic question, a mathematically oriented question, is a little application of classical mechanics or mechanics, you can say, and mostly application of mathematics. Okay. Now question is, for a relativistic particle, acceleration is in same direction as applied force. Okay, so under what condition? So this is a very basic question. See, I have not written anything here because this is very well known thing. Okay, when we discuss special theory of relativity, okay, from discussion of special theory of relativity, it automatically comes out as a conclusion that acceleration and force are in so acceleration is proportional to इसमें क्या लिखा हुआ था Question says for a relativistic particle, acceleration is in same direction as applied force. Yeah, so acceleration and force are in same direction only when force is parallel or perpendicular to velocity. So in these two cases, we get this case. Okay, so this is a very standard conclusion from special theory of relativity. Okay, so that's why I have not written anything, and I reached this conclusion directly. Okay, so if required, we can discuss it in details later on. Okay. So now next question is number of independent real parameters that parameterize any Hermitian 3 cross 3 matrix. Okay, so for Hermitian matrix, number of independent parameter hota hai n square. So it is 3 cross 3, so it will be 3 square. So that is the answer 9. Okay, so 9 is the correct answer. Okay. Now question says electric dipole moment of a charge distribution is independent of choice of the origin of coordinate system only if. So this is a very well known fact that for a charge distribution, electric dipole moment is independent of the choice of the origin of coordinate system only if total charge is zero. So whenever total charge is zero, this dipole moment becomes independent of the choice of the coordinate system. Okay, so therefore B option is correct. So this is a very well-known fact, okay, from the discussion of electric dipole moment. Now, question says, suppose mass of the sun reduces to half its initial value very slowly over a billion years. What will be effect on Earth's orbit? Okay, so if this happens, see, if the mass of sun slowly decreases, Lagrangian will become time dependent, so energy will not remain conserved. Okay, but angular momentum will remain conserved. So if you consider angular momentum conservation, you will conclude that if mass is becoming half, radius effect, roughly, if you talk about a circular orbit, see, I have written down this for circular orbit. So roughly speaking, here question also talks about mean radius. So roughly we are talking about circular kind of orbit. Okay. So radius of circular orbit will become twice. Okay. So if you calculate energy, then energy is becoming E by 4. That means energy is becoming more negative. Okay. Energy is becoming, it is becoming basically less negative, right? So it is becoming less negative. सो एनर्जी जो है यहाँ पे E/4 हो जा रहा है सो बट इट इज नॉट बिकमिंग जीरो और पॉजिटिव ओके इट इज रिमेनिंग नेगेटिव so since it is remaining negative so orbit should remain elliptical okay but obviously radius is changing so therefore radius is becoming twice of r so therefore we'll say that mean radius changes so first option should be correct since see energy is becoming E/4 so initial energy was negative so final energy will also remain negative so if energy is negative there are only two possible orbits okay one is circular orbit and the other is elliptical orbit in inverse square force. So therefore, first option should be the only correct option. Okay. Now, question says, what is the value of this integral? This is a very simple, very elementary integration. You do it using Cauchy residue theorem. Okay, you will get it to be equal to 0. Okay, so that's the correct answer. I have written down few things here related to it. Okay, so that's what we have. I should stand this side because some description I have written here, right? So and now this is a question of 1D simple harmonic oscillator. It says that here for ground state in ground state we are applying this perturbation so question is lowest order correction to the ground state energy lowest order correction means first order correction we have to calculate okay first order correction is coming out to be non-zero here okay so when you do first order correction you will have to basically calculate expectation value of x to the power 4 which is actually a standard result we can do this calculation using operator method okay in simple harmonic oscillator so for ground state, you put n equal to 0 and you just at the end, you just multiply it by lambda because first order correction is basically just expectation value of the perturbative potential. Okay. So here perturbative potential is this lambda x to the power 4. Okay. So when we take its expectation value, the lambda will also be present. So this is coming out to be the correct answer. Okay. Now, next question. See, here it says for a particle in 1D box with width L, इसमें uncertainty in momentum निकालने के लिए बोला गया है. So you do calculation like this. Okay, you will come out, you will get this to be the answer. Okay. Yeah, in the beginning when I was standing here, so basically I was hiding some portion. So towards the end, I will show the slides, okay? Because I was hiding these um, calculations. Now, this is uh, a question related to adiabatic expansion of an ideal gas. So for adiabatic expansion, we know that PV is equal to PV to the power gamma equal to constant hota hai. So here relations are between P and T. So what we can do, we can just remove V from here. So when you use ideal gas equation and you write V equal to nRT by P, okay, and then you put the value of V here, then you get T to the power gamma here, and this is what you are going to get, okay. So therefore, correct option is D. All right. Next is this very simple question. It says there is a ray incident light here. So this is the incident light. Okay, it is going like this and like this. So this is how incident light is going. Okay, so here you can see that it is while going from the denser medium to rarer medium, it is grazing the interface. So therefore, this angle must be equal to critical angle. Okay, so sine theta c must be its refractive index is given to be root 2. Okay, so 1.414 hai, so that is actually root 2. So here we can write that here theta c comes out to be using this formula 45. So here angle of refraction, this is 45, so this becomes also 45. Okay. And then we apply Snell's law here. So from there we are getting theta equal to pi by 2. Okay. So therefore correct answer for this one should be pi by 2. Now, next question. So this is a question related to Carnot cycle, okay, Carnot engine. So this is the efficiency formula. Its efficiency is given to be 50%, that is half. So you do this calculation, you get temperature T1 to be equal to 300. When we put temperature here, we put in Kelvin. So we got in Kelvin, and then we convert it into Celsius. So degree Celsius. So that is the answer. Okay. Now, next question. It is a question from special theory of relativity. It says that particle is moving with velocity Vx, Vy equal to c by 2 in frame. So we have to calculate Vy by Vy primed. Okay, so Vy is velocity, y component of velocity in S frame, and Vy dash जो है, that is the y component of velocity in S dash frame. So these two ratio we have to calculate. So we have this formula. Okay, you plug in here value of V, which is given to be c by 2. This is the value of S dash frame. Okay, and Vx is given to be c by 2 here. So you put all these things. Okay, from here you are getting Vy by Vy prime is equal to root 3 by 2. So which can be written as sine pi by 3 and cos pi by 6 also. So perhaps it has two correct options. Okay. So these two should be correct options. Okay. Now question is there is a time average electrostatic potential. This is the time average electrostatic potential. So question is what is the charge density? So remember here this potential you see there is a factor of 1 by r coming. Okay. When it gets multiplied with this, you will get exponential multiplied by 1 by r. Okay. So whenever actually this uh, potential contains 1 by r, if you calculate the charge density, you will get Dirac delta function. So I asked a student, he told me that there was only one option which contained Dirac delta function. Okay, so therefore that option will be correct. The option which contains Dirac delta function. Okay, other options cannot be correct. Okay, so whenever one by r is present, only that option is correct, which contains Dirac delta function. Okay. So therefore, the option which has Dirac delta is this much. This was the option, so this should be the correct option. Okay. Now, question is this is a question from mathematical physics, a very elementary question. Okay, divergence of r to the power 4 multiplied by r vector is to be calculated. So this you can write like this: r power 5 r cap. So basically, you have to calculate divergence of this. So component of vector is basically radial component of vector is r power 5. Okay, so there is divergence formula like this. Okay, here you take radial component of vector, and from there you get this 7 r to the power 4. So that should be the correct answer. Okay. Next question. So it says that wave function in 1D. So wave function in 1D for a free particle satisfies this equation. H bar we have to take to be equal to 1. So question is what is the magnitude of the momentum? Okay, so just compare it with Schrodinger equation. Okay, and take potential to be equal to 0. You have to take potential to be equal to 0. So because it is a free particle, so you have to take potential to be equal to zero. So when you do that and comparing with Schrodinger equation, you should be able to get this. So it is a free non-relativistic particle we are saying. So energy should be equal to p square by 2m. Okay. So when you do this calculation, okay, you will get p equal to 2. So correct answer for this question should be p equal to 2. Okay. Now next question. See, this is a question. It says that given that mass of proton is this much and mass of deuteron is this much. Okay, so find the fractional shift parts per million of the ground state energy of the deuteron atom as compared to hydrogen atom. So fractional shift will write like this. So actually, energy is proportional to. We know that it is proportional to reduced mass. Okay, so other factors will all cancel out. Okay, so here we just write reduced mass terms of these energies. So when you do this calculation, you will get here 272 divided by 10 to the power 6. So therefore parts per million bola gaya. So that's why we'll say answer should be 272. Okay. So these were total 26 questions that I received from students. Okay, so this was the these were the memory based questions, and I have discussed their answer. Solution I have written down here. Okay, I did calculation on the board itself. I didn't do any calculation on paper. So whatever calculation I did, I have done, shown it here on the board. Okay, so on the basis of these calculations, I have given the answer. All right. So that's all in this video. And as I mentioned, if you have any query, okay, you can contact us on this number, which is the official number of Optimist classes. Okay, thank you very much.